So up to this point, we have just been solving radical equations where the index is 2. For our final topic today, we will be talking about solving equations with a root index greater than 2. So when you see this, it's still the same process for solving a radical equation. It works for everything. So over here, step 1, it says isolate the radical. So we notice there's 2 radicals, and they're both isolated. So for step 2, we now want to raise each side of the equation to a power equal to the index. So in this case, our index is 3. So what does that mean? So instead of taking the squared, like the last sections, now we're going to take the cube roots. So this becomes, so the cube root of 3x plus 10, we're going to raise that to the third power, and we're going to raise the cube root of 6x plus 4 to the third power. Right. So now, so we take the cube root and we cube it. This just gives us 3x plus 10. Over here, same thing. So this is 6x plus 4. Since there are no more radicals, we can just solve for x. Right? And because there's no x squares, we don't have to factor anything. So just solving for x like normal. It's up to you where you want to, but normally I like to subtract the variable so that the variable is positive. So I'm going to subtract 3x over, so that gives me 10 is equal to 3x plus 4. And then I'm going to subtract 10 over, so that gives me 6 equals 3x. Lastly, remember we want a coefficient of 1 in front of the x, so we're going to have to divide both sides by 3. When we divide both sides by 3, we get 2 is equal to x. Or you can also say x is equal to 2. Right. So just like the previous sections, we still have to check our answer. Right. We want to check to see if it satisfies. So for x equals 2, so we're going to check the cube root of 3 times 2 plus 10. Does this equal the cube root of Does this equal 6 times 2 plus 4? Right. So 3 times 2 is 6. 6 plus 10 is 16. And then over here, 6 times 2 is 12. 12 plus 4 is 16. Right. So these are obviously equal because they because they're the exact same, right? And then there's no perfect cube. So if you wanted to, if you wanted to go even further, I can stop here. Hey, but if you don't want to, so for 16, and this is also good practice. For 16, so 16 is not a perfect cube. So what are we gonna do? We're gonna look for the cube root, the greatest cube root. So for 16, I'm gonna go up here, and I'm gonna put this as a product of prime factors. So 16 is also 2 times 8, 4 times 2, and then 4 can go to 2 times 2. So it's 2 times 2 times 2 times 2, which equals to 16. So we can do this as a cube root of 2 to the 4th. Right. So we know from the simplification, if the power is higher than the index, then we have to simplify it even more. So this can become, this is the same as cube root, and then 2 cubed times 2. Right. How did I do that? You can just do 4 divided by 3, then you'll get 1 with a remainder of 1. So we'd have 2 cubed times 2. And if we do that, if we multiply them, we do the exponent rule, and we can add them. So this is the exact same. Oops. Right. So if we do the multiplication property and all that, this the cube root of 2 cubed times 2, this becomes 2 times the cube root of 2. And this is as simplified as it can get. Right? So that was just kind of a little review on simplifying radicals. But like I said, if you want to stop here, that is perfectly fine. You don't need to do all these extra steps. So what does it mean when both sides equal each other? That means x equals 2 is our solution. So for our last example, we want to solve the fourth root of 3x plus 1 plus 5 equals to 3, and we want to solve for x. So same steps as above. This is still a radical equation, right? We just have a different, we're just working with a different index. So step 1, we want to isolate the radical. So the radical is right here, and it's with a plus 5. So what am I going to do? I'm going to subtract 5 from both sides. So this becomes the fourth root of 3x plus 1 is equal to negative 2. Right? So alarm should be going off. There is a negative right here. So when there's a negative, you want to check what the index is. So in our case, the index is 4. 4 is positive. Since it's positive, there is no way this fourth root can equal a negative number. So what does that mean? That means this is no solution. So we didn't do any examples when we have a cube root equal to or an odd root equal to a negative number. But so your question might be, can we solve it? The answer is yes. Why? Because, for example, like the negative 2 cubed, that is negative 2 times negative 2 times negative 2. When we do that, we get negative 8. Right? Even if it's like negative 1 to the 5th power, this is negative 1. So when you have odd roots, you can still have a negative under that root. So if I asked you, what is the cube root of negative 8? The cube root of negative 8 is negative 2. But if I asked you, what is the square root of negative 4? That is not a real number. Right? So that's the difference between even roots and odd roots. So, but in this case, because it's even and we're equal to a negative, there's no solution.